All right, hello. Today's presentation is called Preparing Correct Molar Solutions. And here's what we're trying to accomplish today. What we would like to do is have a broader and a deeper understanding of what concentration, actually means. Well, how are we going to accomplish that in this presentation? Well, I thought what we might do today is take a look at how, a chemist might actually prepare a certain solution of a certain concentration. I think then if you can kind of see, maybe how that might be done, at least mathematically or, fractionally, you might have a better understanding of what concentration actually means. And to give it just a real quick basic definition, if I have if I have a certain volume of water, pure water, and I put something in it, like let's say I want to make an acid or a base. So I put whatever this item is in water, well, I anticipate that it's going to ionize or it's going to dissolve or dissociate. Well, when it does, it's going to create certain ions. Well, my concentration will literally be how many of you, so here, these ions that are created, how many of you do I have per unit volume? Well, obviously, if I have a whole bunch of you, then I'm concentrated. What if I don't have very many of you? Well, then I'm not very concentrated, all right? But I think if you can understand how, we might actually prepare a certain molar solution, then you might have a better understanding of concentration. So here we go. We're not going to really focus on this, but I do want to mention it, and I want to mention this first slide right here because there's more than one way to look at the concept of concentration. Here you have a bottle, and this bottle has a label on it, and it says 0.9% sodium chloride. Well, sodium chloride is obviously salt, so what are you doing here? Well, you know what you're doing. You're creating, pretty darn dilute at only 0.9%. That's not much of a saltwater solution. But when you see this particular percentage sign, then this is a way that you could look at concentration. And in this way, you would literally take the mass of the solute. Remember, the solute is what you're adding. So in this case, it would be sodium chloride. You would take your mass of your solute per given volume. So you would literally be looking at it in grams per liter. Now, in this case, you take your grams per liter, you literally do your math, multiply by 100, and you get a percentage. But I'm going to be honest with you, this isn't my focus today. I'm just mentioning this because there's more than one way to look at concentration. What do I want to focus on today? Well, I want to focus on molarity. And I'll tell you why. It is not uncommon for you to do a lab, or you'll do a lab in college or whatever, where you will be told that you need to use a solution that has a certain molarity. In other words, you might be told that you need to use 100 milliliters of 0.5 molar solution X. Well, okay, what does that mean? But better yet, how would you do it? How would you make it? How would you prepare that? And I think maybe if you can have a better insight on that, you might just have a better understanding or insight on what concentration means, universally or as a whole. So we're going to look at molarity. And molarity is not the amount of mass per given volume, it's the number of moles per given volume. So in other words, moles per liter. We're going to stick with this idea of a liter. So by our definition, if I had a 3 molar solution of sucrose, I would have 3 moles per liter. Okay, by our definition right now, if I had a 3 molar solution of sucrose, that would be the equivalent to 3 moles of sucrose per liter. Okay, so we're going to look at, and we're going to begin with molarity. And what is molarity? It's a way of expressing concentration. So what I want us to do is I want us to make 2 solutions together. We're going to make a solution from a liquid and a solid. In other words, we're going to take a solid, we're going to put it in the liquid, right? And we're going to make a certain molar concentration. Then we're going to make a liquid and a liquid. So instead of mixing a liquid and a solid, in the second example, we'll mix a liquid and a liquid to also make a certain concentration solution. Okay, it'll have a certain molarity. In other words, certain amount of moles per volume. All right, let's begin with a solid. So we're going to assume that we have copper sulfate. But here's the deal. Okay, that's what we're going to have. That's our solid. But here's what we want. We are told that we want 500 milliliters of 0.5 molar copper sulfate. Now, don't get intimidated by that. I thought you said we were going to do liters. Well, what is 500 milliliters? It's half a liter, right? So 0.5 liters. And what is this? Well, this is the information about our what? About our concentration. So in other words, what we want to do is we want to take some of this copper sulfate, we want to mix it in to a known volume, okay? This is what we want. We want 500 milliliters total, but we want the concentration to be 0.5 molar. So the question is, well, how do we do that? How do we figure out how much of this we need? Well, here's what we do. We simply take our desired volume, which is 0.5 liters. Remember, 500 milliliters, 0.5 liters. We're going to multiply that by our desired concentration, our desired molarity. Remember, molarity is moles per volume. And we're going to multiply that by our molar mass. Why? Well, follow the units. We know that liters need to cancel out. Well, this is the molar mass of copper sulfate, so that's really 1 mole of copper sulfate. Well, what's that going to do? That's going to cancel out. So I'm going to multiply my desired volume times my molar concentration that I desire times the molar mass. And what's that going to tell me? It's going to tell me how much copper sulfate I need. So if I run the math through, it's just simple math. It's 0.5 times 0.5 times 159.6. I'm going to get 39.9 grams of copper sulfate. Well, what's that telling me? It's telling me that I'm going to add 39.9 grams of copper sulfate to my container. I'm going to fill that to a volume of 500. Now, I didn't say I have 500 and I add 39.9. I want 500 milliliters of total volume. So I want the water that I put in and the copper sulfate that I put in to have a volume of 500. Now, what will that give me? Well, that will give me a 0.5 molar solution of copper sulfate in a volume of 500 milliliters. Well, so what did I just do? I just made a solution that has a certain concentration using a solid and a liquid. Because what is the idea behind concentration? Well, the idea behind concentration, when we talk about molarity, we want to have a certain moles per given volume. So that's how I would make a solution if I had a solid and a liquid. And that's how I would get the concentration and the volume that I desire. Okay, well, what if, am I always going to have a solid and a liquid? And the answer is no. Sometimes you're going to go to the cupboard, so to speak, the chemistry storeroom, and you're going to say, okay, this is the really, the high molar. This is a really high molarity. This is my concentrated sulfuric acid. But I need to make a solution that is not as high. Okay, I need a less concentrated solution. Well, come on. I think common sense, you already know what you're going to do. You're going to add distilled water, right? You're going to dilute it. But how do you know? How do you know what to do? How do you know how to get what you want? I mean, how do you know how to get the desired concentration that you want when you're adding a liquid to a liquid? Well, here's what you're going to do. You're going to use a very important relationship. You're going to use M1 times V1 is equal to M2 times V2. Well, your M's are going to be your molar concentration, and your V's are going to be your volumes. Now, I don't want to oversimplify this and I don't want to overcomplicate it, but I think you need to think about something. What are you doing? You're going from a higher molarity and eventually you're going to want a lower molarity. Well, so what are you going to do? You're going to add water to it, but how much do you need? What do you need? How much of this do you need? How much of that do you need? What do you think is going to happen? Don't you think probably if you're diluting, then you're going to have to add water, and so your V's can change and your M's are going to change, but at the end of the day you want a relationship that shows the same thing. Okay, so you use this M1 times V1 is equal to M2 times V2. You fill in all of the information that you know and you solve for what you don't know. In order to do what? In order to create a liquid solution, an aqueous solution that has the molar concentration that you want, because this is all about concentration. So what do? You fill it in, you rearrange, and you solve. But let's have a problem. So here goes. This is the last item that we're going to look at. We're going to look at a liquid and a solid, which we've already done. Now we're looking at a liquid and a liquid. So what do you know? It says, how do you prepare 100 milliliters? So what do you know? You know how much you want. You want 100 milliliters of volume of 0.4 molar magnesium sulfate from a stock solution of 2 molar magnesium sulfate. So in other words, this is kind of a similar problem to before, that you have a higher molar, okay? And what are you going to do? Well, you're going to mix it with water, and you would like to end up having a solution, only 100 milliliters, but you want a solution that obviously has a lower molarity, right? Well, here's the question. So how are you going to do it? Well, you're going to mix these together, but how much of each do you need? How much, you want a total volume of 100 milliliters. So it's not like you don't know how much you want to end with. What you really need to know is how much of this do I need, right? So how do you do that? Well, you find what you know. So you know your M1. You know your molarity at the beginning of your stock solution is 2 molar magnesium sulfate. Well, how come we have unknown for V1? Well, because I don't know how much of that I need to put in. I know I need my total volume to be 100 milliliters, but I don't know how much of that I need to use because I haven't calculated it, right? I know what my M2 is because I know what I want my concentration to be. This is what it is. This is what I want it to be. And then I know my ending volume because I know how much volume I want to have at the end. I want to have 100 milliliters. I mean, I know all of this from my problem. So I know where I began, I know where I want to end, and I know how much volume I want to have at the end. But I tell you what I don't know. I don't know how much of this I need to use. So what do? Well, I set my problem up. But I tell you what I really do. It's simple algebra. If I'm going to isolate V1, then I'm going to have to divide both sides by M1. So I'm going to divide both sides by M1, which is going to cancel out my M1s, and I'm going to be left with V1 is equal to M2 times V2 over M1, which is exactly what I show you here. So when I do that, magnesium sulfate cancels out. The only unit that I'm left with is liters. When I do my math and I solve, I get 0.02 liters, but I really wanted to know how many milliliters I need. So I'm just going to simply multiply that by 1,000, correct? So when I do that, I'm going to move my decimal place 3 places, and I'm going to get 20 milliliters. So how much of this do I need in my 100 milliliter volume? I need 20 milliliters of this. And so if I take 20 milliliters of this in my 100 milliliter volume, I will produce a 0.4 molar solution. So I will have the concentration that I want. And that would be how I would do it if I mix a liquid and a liquid.